Hey Wizard, so if you've had thoughts about can I build a bot to learn to trade by itself using AI technology or what I'm going to refer to as reinforcement learning in this video, I think this will be worth your time and it might be a slightly long one. If you're just interested in the concepts here and you like following what we do here on the channel, I think anyway you're going to get a lot from this because it'll also tell you about how I personally, whether it matters or not, how I personally think about how reinforcement learning, or more commonly referred to as AI, could be applied to the problem of stock trading and cryptocurrency trading. So we're going to go into that in some detail here in this video. I've spent a long time on this. It's only in the last week where I really just put a lot of acceleration on it. But over years, I've sort of dabbed in and out of this topic. And often really what put me off was the math. Very quickly, just wanted to give credit to Anis Amrain for this really cool 3D artwork. Thank you. I think it made this video a bit better. Anyway, the math is what has put me off in the past, because even though I can spend the time to understand, for example, here the Bellman equation and all this stuff, it just felt like it was a barrier for me because I'm more sort of bootstrap, brass tacks, let's get on, let's build something functional. I know from a trading mindset what I wanted to do. I know as a developer what I enjoy coding. The math felt like it was just getting in my way. And so I've come up with a methodology, and this is to help those of you who might struggle with the same thing. I know there's a lot of folk here on the channel who love the math and think the math is absolutely vital if you want to be able to do something like this, and I get that. But for those of you where that's actually been a deterrent and it's actually prevented you doing what you want, this is how I've overcome that. So first of all, this is the course I recommend. I'll put a link to it. By the way, I don't think I've ever linked to a Udemy course before. So there is a chance I might get a referral commission for that. So by all means, if you're not comfortable with that, search for reinforcement learning beginner to master on Udemy. Otherwise, I'll put the link in the description. I've never linked to a Udemy course that isn't my own, but I've done 92 courses now, or at least bought 92 courses. This is one of the handful of those that I've just gone start to finish on. If you ever want me to do a video on what Udemy courses I've found absolutely phenomenally good, just ask in the comments. I'll be sure to do a quick video on that. But this course here, what I like about it is the train is excellent. It's done by Escape Velocity Labs. They do go through the math, but what they do is they put the math up on the screen, but they explain the principle on what it's trying to achieve. And they explain that. So what I've been able to do is watch those videos and go, okay, I get what the math is trying to do, but what the trainer also does is they go through each line of code. And so what they'll do, and I'll just, click around as I'm talking here. So for example, if I go to the coding section here, they will actually explain what they're doing.
It will be a vector of 64 elements.
Here, I'll stop talking for a second.
And it will have an output.
You won't be able to see this because I'm recording my screen. It won't show my screen, won't show the trainer. But here you can see them speaking.
That will be a vector with the number of available actions.
And so what he's doing here, you can't see it, but what he's doing is explaining what that line of code is doing. And so what I'm doing is I'm saying, okay, if I go and take, for example, and this is where I'm taking my notes, etc., usually in the format I teach in, I'm also taking notes in that format. What I'm doing is I'm putting together flow diagrams of what these concepts are and then connecting it based on what the code is doing. And that is then how I can review and understand, oh, okay, I get it. That's what he meant by X, Y, Z. This is how it's working. And now I know exactly how to go and build this reinforcement learning algorithm. There's no math. You can see there's no math on here, right? I understand the gist of it. I've got access to the code. I understand what elements do what. If I want to tweak anything, I understand what it's doing. Now, does that mean I could compete with the wizards here who know math, who are very good at that, who know machine learning, who are very good at that? Absolutely not. And nor do I intend to. I'm much more of a generalist. But this is what has opened the door for me. And so this approach has really helped me to learn. So hopefully this has also helped someone else. If this has helped you, feel free to put in the comments. I'd be most grateful to hear back. So this is what I'm doing. So for example, this is one of the AI algorithms. Here I'm going to tell you more in this video about what these things are actually doing now. So for example, this is what reinforcement learning is. So if I just go to this very, very basic graphic here as an example, you have here your AI bot, your reinforcement learning brain, call it. And what it's doing is it's getting put in an environment, right? So you're giving it an environment to interact with. And so this environment in terms of code is just a class. It's just a Python class, right? It could be your stock trading environment. It could be a poker playing environment. Maybe you want to develop some reinforcement learning to beat people at poker who turn up drunk at 5 a.m. and you want your bot to beat them. Cool stuff stuff that I think is cool. Stuff like that, right? Anything you want. Could be it playing chess, could be playing Super Mario, whatever it is. You've got this environment you want to interact with. For us, it's stock and crypto trading. And so what this bot is doing is it's going to take an action. So here it is, it's in this environment and it says, okay, I'm going to take an action randomly. I'm just going to pick a random action, and that's going to be to take a step forward. And so this environment might say, okay, actually, here's the value of what you just did here's the feedback in terms of how well you just did. And so the environment will give them a reward. It will say, hey, this was a good move, or this wasn't a good move. If it was a good move, it'll give them, say, a +1. If it was a bad move, maybe it'll give them a -1. It's not always quite that simple, but you need to get the gist of what's going on here. It's using math. So the algorithm is in the algorithm always really is this max. It's trying to get the max number, the maximum possible number, and then it will take that and use that for the future once it's learned. So it's using math to get rewarded here. And so it's been given a +1, and then it goes and adapts its thinking, and we'll talk about some of the ways it does that. There's different ways these bots can get built, which I'm not going to go into detail of. I'm just going to jump straight to the advanced stuff here, or what I think is the advanced stuff here. Because that's more than likely what you're going to need, by the way, if you want to build a bot that actually trades in the stock market. You're going to need that. So it gives that reward, but what it also gives is the new state. So it's going to say, okay, so you made that decision. Cool, good decision, or not. Here's your reward, but here's the new state you're in. So in the case of this maze, the state would be, okay, you're now on row 5, column 2. That's your position, right? That's the state. If this was stock trading data, it'd be, okay, now your open positions this, your closed positions that, your new account balance is this, whatever. Like that's the state. Here's the previous close, here's the volatility, whatever you program in. So that brings me to a very key point here. Really, the art here is not so much what algorithm you choose, which is highly important, by the way. I'm not going to poo-poo that. It's very important what algorithm you choose. But really, what I'm learning here, being at the beginning of this journey myself, is that the environment you build and how you decide to reward that agent is really paramount. Because let's say you want your agent to trade based on the size of the spread. So maybe what you're building, this is not what I'm building, but and I'll chat more in the Discord for anyone who's interested in kind of what I'm building towards here. But you might be wanting to build something like a market making AI bot, right? And if you're doing that, you might be interested in what is the spread between the bid and the ask on the order book. So you could feed it in bid and ask information and the size of the spread. That could be part of your state. And then let's say the agent decides to take an action which is favorable, i.e. it places a limit order at a really good point. It earns you a commission, in your trading, in your simulation, in your trading environment. And by the way, trading environment, we're talking about a glorified spreadsheet with some Python code. By the way, nothing super advanced in terms of you don't need to build software for this. But, it might say, okay, cool. You took advantage of a spread that popped open and closed +10, right? There you go. Great. Or you didn't get your limit order filled. So it gives you like a little hit, a little -1, for example. This gives you an idea of anything, right, that you can put in your environment in terms of reward and state is going to influence your bot dramatically. And so it becomes less about the algorithm and more about how you think you should incentivize that bot. And one of the things that I was listening to, I forget which YouTube video it was now, but somebody who's been doing this at a much more professional level, they're like, for example, it might be a good idea to incentivize your bot on something like the Sharpe ratio, which says for every dollar of risk I'm taking, how much return am I getting? So you could calculate into your environment the Sharpe ratio based on the action that just got taken. And if the Sharpe ratio improves, etc., it's getting, it's getting rewarded or positively or negatively rewarded based on that, as an example. So that's really what the general concept of reinforcement learning is. Now let's take it up a gear here. So here we have some neural networks. I'm not going to go into the detail of neural networks for this video because I think it's going to be long enough anyway. But for those of you who don't know what a neural network is, this is deep learning, right? So deep learning is basically, you've got a bunch of artificial neurons, just like the human brain. But instead of being the human brain, these are just math functions. And you don't need to know to code them because there's libraries you download that have all that code built in, right? So I'll actually give you an example of a neural network, what it looks like in code. So if I go down over here to one of my neural nets based on the course I was going through, let me just find it here. Excuse me, here we go. I've got 2 neural networks. That's the amount of code. This here is an artificial brain, and it's 1, 2, 3, 4, 5, 6, 7 lines of code, right? It's actually coding this stuff is the easiest part of machine learning. I always say this, the machine learning algos themselves are like, XGBoost is like 1 line of code, right? To actually go and train that thing, because it's all done under the hood. So that's what these are, though. These are like these artificial brains. So they will take in the state, right? What is your open price, your close price, your volume, your volatility, whatever you want to feed in. They will take that state in. And for those of you who are interested in the coding, those, if you're using, say, PyTorch, for example, they need to be in the shape of a tensor, right? Which basically just means an array, right? A special type of array. And so that's not exactly what it means, but it's close enough. And so that, that's what they're taking in. And then they have all these connections, and then they give you an output. So, it's just like if I feed you sugar, your output is joy. I love sugar, right? If you're anything like me, you love sugar, great. Your brain, it's taking an input and it's giving an output. So in here, you're giving this bit of code the input of the state you're in. And then what it's saying is okay, cool. You're now at, this price, you're at this time step or this step in time or this state. And therefore, here's your output. Your output is you need to now go long on Bitcoin, or you need to now place a limit order, or whatever it is you're deciding your actions are, you need to go and do. And so how does it know what actions there are, right? So we've talked about state. The state is whatever you put in. The actions are what you decide its possible actions could be. And you have 2 different types of actions, right? So if you think of something like a self-driving car, a self-driving car has a continuous action space because that degree of that steering wheel could be 0.1256, right? It could be anything, But a discrete action space is something like buy, sell, hold, right? It's very sort of binary, or it's very discrete. And so depending on your action space, you can decide, okay, is it a continuous action space? What are the available action spaces? I could have my steering wheel plus my gears. My gears are discrete, but my steering wheel is continuous. It's just an example there. For trading, I use discrete, and I do this as well with XGBoost. As you know from the Crypto Wizards platform, we have a machine learning model there as well that does all sorts of stuff. But it basically, my favorite type of problem to solve is classification. It's a discrete problem. And for trading, I actually believe this is very important. Like, keep it as simple as possible. So that's how you define your action space. So what this thing's doing is it's saying, okay, let's take this action. And that action gets fed into the environment, which is your Python class. And your environment then kicks back some feedback, and it says, okay, first of all, are you done trading? Did you get to the end of the data? And usually the answer is going to be no. It'll also kick back the state that you're now in, just like we saw in that earlier slide, and it'll kick back your reward. Now, in this particular algorithm, the advantage actor critic, that state is fed into two different brains. That sort of, there's a critic of what we call the actor. And so what's happening is this state is here fed into the critic, and this critic comes up with a value, so the next state, and the value for that next state, and it comes up with what's known as like an estimate. And then that reward and that estimate gets used to compute something called a target. And so the state that goes into that critic, the next state goes into the critic, which feeds the next state value. The current state goes into the critic, which gives you a value as well, and that value is compared to the target. And then depending on how that algorithm, that deep neural network is structured, it computes something called the loss. And depending on how it's structured, that loss then gets back propagated, and its brain connections, or the strengths of its brain connections, get adjusted. And this process just happens iteratively all the time. At the same time, this brain is also getting adjusted, or maybe at a slightly different point in time, depending on how you built the algorithm. But these two brains are getting adjusted just through some code. And, so those two brains are getting adjusted, and they're getting more and more smart over time. And they're learning about the relationships between the state and the action they took, and what sort of reward did they get. And you can see the reward here is part of what makes up this target, which is what calculates this loss, which is what decides how should the brain connections change. I'm using very loose terms here. And by the way, please do, for those of you who are total experts in this, who think this is a terrible explanation, and you really want to correct me on anything, please feel free to go and do that. But just loosely speaking, this is really what's going on here, right? And so what you end up with is this actor here, who now has been very well trained, because this this loss here of this critic criticizing the actor has also been propagated to this actor through something here called the advantage, which is basically a function that uses something called entropy, which, by the way, you learn about in the video, right? So if you go through the course, you learn about what is entropy. It basically it's like an adjustment on randomness and stuff, and it's actually really interesting. What it does is it adjusts this brain here. And this is known as the policy. The policy is basically the function that decides what action should I take. That is what the policy is in reinforcement learning. So here we go. So we have this, advanced advantage actor critic algorithm. What does this actually now look like in code? And so one of the things I mentioned to you is that the environment is really important. And so I'm going to link to this as well towards data science. Adam King wrote an excellent blog on this. It's really good because it teaches you about creating your own stock trading environment for reinforcement learning. And so if you want to create your own stock trading environment for reinforcement learning, this is a great place to start, because I plugged it in and it works. I'm actually going to run it for you now. So here I'm using Google Colab. I recommend to use that. I'm using an M1 MacBook, and I don't know if this is why, but my Jupyter notebooks kept crashing for this particular approach. Here is where I've coded from scratch through the course I did. This, the flow diagram I was showing you, here's what it looks like in code. It's basically a series of neural nets, and then this here, let me take you through it. I won't go into detail. This is the environment here, and then down here, this here is the brain, right? This is the thing connecting the brains together. This is the agent, basically. So one of the things you can do without having to know how to build your own reinforcement learning algorithm is you can actually use stable baselines. And so, for example, stable baselines has this tab on it, RL algorithms, with a list of some of the most advanced algorithms there are. I mean, this TD3 is used for self-driving cars. It's like incredible. And literally, it takes one line of code to change for you to all of a sudden have a completely different algorithm that you're now training. And you can train different algorithms and see how they compare to each other. So, I'm using this to try to help me figure out what algorithm performs the best. And then I'm going to be using the course material that I get from, this gentleman to get the right sort of code so that I can then actually not rely on this Python library, but build the code from scratch and really fine tune it to see can I improve it. But I think from what I've seen on papers that have been published, the best trading reinforcement learning approaches are actually ensembles. So what you would actually have is you would train an ensemble of these and then decide to use the action that, say, was the most favored amongst all algorithms. And then it appears that an ensemble actually outperforms any one of the algorithms individually. Really interesting, hey? So there you go. So let's actually now go and run one of these. I'm aware this has been a very long video and probably quite painful for people. So let's go and run this. So what I'm going to do is I'm just going to hit Shift and Enter. And this is just going to, for example, make sure that everything's installed. And if I just look here at sample data, I actually don't have any data in here right now. So what I'm going to do is go to my downloads because I've just got this from Crypto Wizards. You can get it from Yahoo Finance for those of you who aren't Crypto Wizards, but put in whatever you want to trade, right? So here, for example, I'll put in Apple. I'll just log into Crypto Wizards quickly. So what you want to do is just go over here to Data Builder. You can open that, so Data Builder. And let's say you want Google, Apple, or whatever. Let's say you want crypto, actually. I'll get it from Binance. You could just put in something like, Ethereum, BTC, or whatever. Let's say you're going to do daily. The more data, the better. Get the maximum data you can for daily data. And, then just go, BTC, Ethereum, BTC. Save it whatever you want to save it as. And just go and run that, essentially go and run that data, get whatever data you want. If you want foreign exchange or whatever, then go through FMP to get that. Then go to Data Engineer and just hit download, right? So here, just click this download icon, and now you've got that data, right? So once you've got that data, you can then add columns to it, or if you want to, you can use Data Engineer. This is not a video about, Data Engineer, but you can go to Data Engineer over here, click on one of the tabs like Transform Features or TA, add in any of your TA you want to, whatever, right? Just do all of that, get your data. When you have your data, you need to just drag it in here. So this won't work for you, for those of you on the Discord, unless you have data in here. So just add it into this folder here, which is your data. All right, and so then you just basically Shift and Enter everything. And make sure that when you bring in the data, you just change this to whatever the file name is that you brought in here. You just change that here and Shift and Enter. And there you go. You just keep going. And now it's training. So now it's training over 50,000 time steps or whatever. And by the way, this is just half, not even half put together ready right now. I've done a very, very poor job of actually preparing this for anything meaningful, but it's working and it's a good starting point to then go and modify code. And it's using here stable baselines. And I've actually got one as well. I'm not going to link to yet because I want to play with it more, but I've got, a custom from the ground up built one without using stable baselines here as well that I'm going to be, playing with. So this one here, you can see it's now done 8,000 rows, 8,000 time steps here. It's going to get up to 50. And then what I'm going to show you is how can you check and see how well that algorithm, how good is that actual algorithm doing? And then how can you see where it placed trades, etc. So I'm going to show you that. I haven't actually coded that in yet, but just to show you what you would do next to, you have a number of ways you could do that, I guess. But I'm just going to do it the very basic way because I'm a basic guy. I just want to see stuff working. And then I test it, I get it working, and then I advance, right? So this is how I sort of do it. I start at the very basics, like from a blog, from some courses, and then build up from there. And then, what I will do is test this in the wild with on testnet, depending on what bot I'm doing. If it's market making, you'd probably actually have to test it with your own money in mainnet. But that's the approach I would take, right? And forward test that bot and see how it performs in the actual wild, right? So here we go. We're near 50,000 now. What are we at? We're at 36,000 time steps, and this isn't very long, by the way. You could train this thing for hours and hours and hours and hours and hours. It depends on the algorithm. It depends how it's behaving based on the time. Remember that markets follow a random walk. So what we're training this thing to trade here with Apple, for example, here it's using Apple. It's using open, high, low, close information. I can tell you now, this bot is next to useless, right? And it's going to be massively overfitting here. etc., which are all problems that you would have to overcome, right? This is a challenge. This is a very hard problem, make no bones about it. And I think when I checked this and I had it print out the profit before, it was like making, $46,000 in profit, like hundreds of percents. No, it's probably just really overfitting. And therefore you might have to introduce some noise, etc., into the training process and all sorts of things. Anyway, here there's some text here I found which is very useful. I actually found it based on another course I bought from the same person. And this is, again, I might watch one or two videos and then I get something from them. But this is a good way to actually go and get that information into TensorFlow so you can actually see how this thing performed. And so I'll show you that in a second. The only thing you need to adjust to the blog is just put in this Tensorboard Log and tell it where you wanted to save that file. And then down here, you give it that same folder name here, whatever you called it. So there you go. And so now what I can do is uncheck this ignore, outliers. And this tells me how this algorithm's performed. So here's that entropy thing I was talking about before. Here's the learning rate. What I'm interested in is the policy gradient loss. So this loss has actually gone up. I think that's a bad thing from what I'm learning. I think the loss should be going down. Here it's sort of got this loss here. It's jumped up. Now it looks like it might be going down. What this means is I probably haven't trained this thing enough, plus, and or it's got too much non-useful data. And so this all becomes about what is the reward you're giving your bot? What are you rewarding it based on? What data are you feeding in as the state? And are you giving it a meaningful problem to solve and taking away decisions for it, i.e. what percentage of capital to use? That should be how you should code that in your environment, I think, not make the bot have to decide that. These sort of things, just condense down what you're trying to solve. This is just the stuff from this guy's blog, right? There's nothing going on in here that's going to make you rich. Coded in here, but this is what I'm telling you, like I'm learning you really need to play with is how do you want to reward it? And here is that custom environment, right? If I go down and I look at, take action, here's the action, that it would take. And then here's the step, here's the reward. And it's basically the reward is the balance times something called a delay modifier that they've created here. I'm not going to use that as my reward for my bot. I'm just not, right? I'm not saying this person doesn't know what they're doing. I'm very grateful to them. What I'm saying is that's what's going to determine how useful your reinforcement learning agent is. And so it's really a long-term journey. I'm not going to have this done for a long time. There are other things that I really want to innovate on and build for us at the Crypto Wizards community, and get out there. But I'm very, very serious about this because I think that because we know a lot of different styles of trading as a community, one of us is going to have a very good idea about how this tech could be applied to a certain problem. And I have no doubt we're going to make profit from it. So, that's my vision. That's my goal. I hope that this had some gold nuggets in it for you, if you're on this journey, because I've found it very challenging, even sort of with the background I have, which is not new to Python. It's not new to data science. And I found this really challenging. I think this is very hard to do. But this is the very start. I hope you found it useful. Until the next one, take care and talk soon.